Primary trig ratios is kind of the starting of trigonometry. So the word trig means measurement of a triangle. So consider, sides, things that we need to recognize when we're looking at triangles is we always need to know things like the hypotenuse, the opposite, and the adjacent. So if I were looking at this triangle here, and I were to label it A, B, C, typically, to be honest, what we used to have is something like this, A, B, C, and maybe I'll do that just to make it easier, because C is always our hypotenuse. The hypotenuse is always the longest side opposite the 90-degree angle. Okay, so we're always going to label that first, H. Now, if we were talking about A is going to be always across from side A. Okay, so side A is always across from angle A. But in this case, side A, so I'm going to label it A, is our opposite. Okay, side C, I'm going to just change the colors here. Side C is our hypotenuse, we've already said that. And side B is our adjacent, because we're dealing with angle A. Okay, so we're going to label it always the same way. Hypotenuse first, then opposite, then adjacent. Okay, and I'm just going to kind of scratch those up. Side A is always across from angle A, side B is always across from angle B, and side C is always across from angle C. Okay, but when you're labeling it, you always have hypotenuse, opposite, adjacent, from whatever angle you're dealing with. The sum of interior angles is always 180 degrees. And the primary trig ratios are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta is opposite over adjacent. So this is, if you remember, SOHCAHTOA. Okay, and you're not going to sound weird saying that because every math class in the world says it. You also might see it written like this, SOHCAHTOA. It just helps you remember the fraction a little bit better. So write the primary trig ratios, sine, cos, and tan for this triangle. Okay, and we're dealing with angle A here. So the first thing we need to do is actually find out what C is, because we don't know it. So we're going to use Pythagorean Theorem. So C squared equals A squared plus B squared. We're going to have C squared equals A is 12. So 12 squared plus 9 squared. So C equals the square root. 12 squared is 144. 9 squared is 81. So we now have the square root of 144 plus 81, which is 225. And then we have to square root that. Now, depending on the calculator you use, you're going to push 225 and then square root button, or the square root of 225, but your answer should be 15. So we now have 15. Now to do our trig ratios, all we have to actually do is write sine A. So first thing I'm going to do though, is I'm going to label it. Label our triangle. We've got hypotenuse. I'm going to write that a little bit clearer. So hypotenuse, go across from angle A, opposite, and then whatever's left has to be adjacent. So we know sine, so from SOHCAHTOA, we know sine is opposite over hypotenuse. So I'm going to write sine A equals opposite over hypotenuse. So sine A equals 12 over 15. Cosi is adjacent over hypotenuse. So cosi is equal to 9 over 15. And tan A is opposite, that's a 9, over adjacent. So tan A is 12 over 9. Okay, and that's all you have to do. You don't have to do any solving or anything like that, because all it's asking for is the trig ratios. Looking here, evaluate the following. So this is just getting used to using your calculator. So you need to first make sure you're in the right form. And you need to be able to get these answers. So depending on your calculator, you're going to push 52 sine or sine 52. You need to be able to do this. If you can't do this, I can't help you. You have to be able to use your calculator. Okay, so now next one. On the phones, or on Apple phones, you're going to push 42 and then sine. It's very important that it says RAD down in the corner. The reason that is if you push that button, it's now changed it into RAD, which is radians. It's just like a different way of measuring. We want it to be in DEG. So if you see DEG down in the bottom corner, you need to push it. Okay, it's like measuring in feet and meters. They don't work together. So we need to make sure that we have both of them understood, but we're always going to use DEG. So if it says DEG down in the bottom left corner of your iPhone, you need to push that button. All right, now the second thing we need to be able to do is find an angle. So we found all of those. Now what we need to be able to do is find an angle. And the way we do that is by the inverse of these functions. So on your iPhone or on your calculator, you're going to push your second button or shift, and it's going to give us the inverse. So now I'm going to push 7 divided by 16, and then the inverse. So this one's going to be 25.9 or 26 approximately. Okay, and we're just going to measure to the nearest degree here. Okay. You wouldn't have to put this first line typically. I'm just doing it to show you exactly what I'm doing in the calculator. So 8 divided by 15, and then we're getting this to be 58 degrees. And then so whenever you're finding the angle, you're always doing the second function. All right, so you need to be able to get those in your calculator. If you can't, you have to practice. Okay, find the indicated values here. So we're finding x, then a, then y. So what we need to do is we need to recognize first our angle. So our angle is here. So we've got hypotenuse, we've got opposite, and adjacent. Now there's no number or variable at adjacent, so I'm not going to use it. I'm using opposite and hypotenuse. And from TOA, the only one that has opposite and hypotenuse is so. So we're going to have sine theta equals opposite over hypotenuse. Now I'm going to start subbing things in. The angle I'm using is 32, so I'm going to have sine 32 equals x over 15. Now I'm going to put some stuff into my calculator. So I'm going to have 32 sine. And I'm going to get 0. And I'm going to just do this to maybe 3 decimals. So 0.530 equals x over 15. To get the 15 to the other side, I'm going to just multiply it. So I'm going to take that number, multiply it, and get 7.9. And that's centimeters in this case. For the next one, I'm going to do the same thing. I've got 36 hypotenuse, opposite, adjacent. We don't have the hypotenuse, so we're using opposite and adjacent, which is tan. So we're going to have tan theta equals opposite over adjacent. So now when we're working through that, we're going to have tan 36 equals 26 over A. Now tan 36 is going to give me 0.727. Now this one's a little bit harder. What we'd have to do is multiply the A to the other side and then divide. But if you look at the last one, if the variable's on the top, all we do is multiply over. If the variable's on the bottom, we switch the variable with the other side. So in this case, we're going to get A equals 26 divided by 0.727. Okay? If the variable's on the top, you multiply over. If it's on the bottom, you switch them. And here you're going to get 36 centimeters. I'll just leave it rounded to 36. And then last but not least, here we're going to go hypotenuse, because we can label that before our angle. We know we're dealing with that angle, so across from it is opposite. And here we have adjacent. Again, there's no hypotenuse, so we're using opposite and adjacent. We've got theta is opposite over adjacent. So tan 44 is 4 over y. We're going to switch those two. So I'll put tan 44 into my calculator first. So you get 0.966. And again, you can leave these numbers all in your calculator, but if you were to just round them to 3 decimals, that's okay too. We're going to switch the y with the 0.966. And then we're going to times or divide 4, so we're going to get 4.14. So we'll just call it 4.1 meters. All right, last one. So we've got this ladder. A ladder is unsafe if the position it makes is less than 15 degrees. It just means that it would topple backwards. So we've got a 10-meter ladder that is 3 meters from the wall. A 10-meter ladder is placed so it's 3 meters. So we know it's 3 meters from the wall, and the ladder itself is 10 meters long. Okay, we don't know how far up the wall it goes. We don't know this, but that actually doesn't matter. What we're going to try to find is this. Okay. Oh, sorry. No, it's the angle with the wall. So we want to find this angle. Okay, so what we have is we have the hypotenuse, and we'll call this angle A. Doesn't really matter. B, C. We have the hypotenuse. We have the opposite, and we don't have the adjacent. There's no number or variable there. So what we're going to do is opposite and hypotenuse. So that's going to be sine. So sine theta equals opposite over hypotenuse. We're going to have sine A, I'll call it A this time, is 3 over 10. And then remember from this slide, we have to do the inverse to find out our angle. So we're going to have sine inverse of 3 over 10. And then we're just putting that number into our calculator. So 3 divided by 10. And then we're doing the sine inverse. You should get 17 degrees. Okay, and we're always just going to round to the nearest degree. So if the angle is less than 15, it is unsafe. Therefore, this is safe. It's 17 degrees. Okay, and here's some questions to try with this.